So we're going to pick up right where we left off and develop another means of describing motion. So before we only looked at the length of the arrows, we then were able to use the definition of the velocity, which we said that the velocity, the average velocity, was equal to the change in the position over a change in time. Now we're going to try to use graphs to describe motion. So what I've drawn here is what we call position versus time graph. So the position is on the y-axis, time is on the x-axis, and now I want to look at my motion diagram to pull out coordinates. So what we can see is at 0 seconds and 0 centimeters, so I want to place a dot at the 0, 0. At 1 second, I'm at 3 centimeters. So at 1 second, I want to place a dot at 3 centimeters. At 2 seconds, I'm at 6 centimeters. So I want to place a dot there. And that's right about here. And at 3 seconds, I'm at 9 centimeters. And that's approximately here. So now what I want to do is now draw a line connecting these. And that is a graph that describes the motion of our robot. But what does this mean? Can we interpret anything from this? And the answer is yes. We can look at the slope of this line. So we remember that slope is equal to the rise over the run. Well, what is our rise? If I wanted to look at this point right here and this point right here, what would I find? So my rise would be going along this axis, so our rise would be a change in the position. Our run is along the time axis, so I'm looking at a change in the time. Now this should look familiar to us because this is what we just wrote over here for the average velocity. So the slope of our line on a position versus time graph is the average velocity. So let's test that out. If I'm looking at this point right here was 9, 3. So we can see 9 centimeters, and that's also 3 seconds. This point right here is 0, so I want to subtract 0 centimeters and 0 seconds. And what do I find? This gives me 9 centimeters divided by 3 seconds, or that my slope is equal to 3 centimeters per second, which is, again, our average velocity.